Alright guys, looking at today's lesson, it's very straightforward. Just learning to apply the properties of parallelograms. Now by definition, a parallelogram is a quadrilateral that has two pairs of parallel sides. That's the very definition. It's a quadrilateral that has two pairs of parallel sides. Now, in the calculator activity you guys did, you found out that there's a lot of different properties. What was the first property you guys learned about in that activity? Don't be afraid to look back at that sheet. What was the first thing you guys found out about parallelograms? Really? Opposite sides are congruent. So let's go ahead and mark that down. So that's our first property of the day. Opposite sides are congruent.
Oh.
So how would that help me solve the problem there on the right?
So b plus 11 equals 2b.
So b plus 11 equals 2b.
And then 3a plus 7 equals 4a.
And then 3a plus 7 is equal to 4a. Any question on how to set those two problems up? So opposite sides are congruent. That's a really important concept to get this down. Opposite sides are congruent. Okay, what was the next property that you guys learned about? Zue, what was the second thing you learned from that activity? And where are those equal angles? Well, it's basically almost the same thing. We have opposite angles are congruent. So our opposite angles are congruent. Tommy? Shout me out here for a second. If my opposite angles are congruent, how can I set up an equation to solve for x according to this example?
2x minus 1 equals 75.
So x minus 1 is equal to 75. Well done. Alright, what was the third thing we learned about? So we found out that our opposite sides are congruent. Opposite angles are congruent. Pernell, what was the third thing we learned? Could you at least put out, can you tell me what that relates to? Okay, about the midpoint. So with the diagonals, right? Okay. So we should learn that the diagonals, whoops, that's the one here, the diagonals bisect each other. So if I draw my diagonals, each diagonal cuts the other one in half. Caleb, based on that, knowing that the diagonals bisect each other, you can give me one equation to solve for either W or for B.
For W minus 7.
Well done. 4W minus 7 is equal to 2W plus 3. And Courtney, what's another equation I could use? Alright, now one of these that, I think which is the last property you guys looked at, it was a little difficult to kind of pull it together, but it had to do with consecutive interior angles. And what we're looking at is, if I look at this corner, and I look at this corner, it was a little difficult to make that connection, but basically what we found out is that those two angles are supplementary. Which means that if I take angle A and I add to angle B, then A plus B must equal what?
180.
180. And that is the same no matter what consecutive angles we use. Now remember when we did parallels and transversals, and we said sometimes we call them the same side interior, and we also might call them consecutive interior? This is where that consecutive interior angles comes into play. And if you think about it, it totally makes sense. If these two lines are parallel, then segment AB is a transversal, so therefore I have same side interior. And if I flip that around, so now that I have AB parallel to BC, BC is now my transversal, and now I have same side interior as well. So no matter what consecutive pair of angles I choose, they're always going to add up to 180. So Ted, give me an equation I can use to solve for either x or for y. X plus 101 is 180. By the way, can I know what y is very quickly?
Yeah.
Why?
Because
Opposite angles are congruent. So since that's 101, angle y must be 101. So therefore, what does that make angle x?
79.
79 degrees. Okay, we have one last thing I want to talk about. Actually, I think that's it. Yeah, that's it. We're pretty much done. Those are the 4 properties you guys need to know. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary.